In this section, we're going to be looking at series. In the group activity, you already saw that a series looked like a sequence, but each term was being added together, 1 plus 2 plus 3 plus 4, and so on. We can write these series in that list showing that we're adding, or we can write them using summation notation. So the sum of a sequence is denoted as, this is a sigma. It is, this symbol is the uppercase Greek letter of sigma. On top, we have n. On the bottom, k equals 1, and then a sub k is our sequence. So this reads the sum of our sequence, a sub k, from k equals 1 to n. So that means we're finding the sum from k equals 1 to n. When we substitute in 1, 2, 3, 4, all the way to n, what is the sum of that sequence? So let's take this series and let's write it in the other form, summation notation. All right, so if we're going to write it in summation notation, it's going to end up looking like this. All right, so that means we're going to have to find our equation, our explicit equation for a sub k. Okay, so that's going to be step 1. Okay, so we need to find an equation for a sub k. Well, let's see. If I take a look at this, it looks to me like this is an arithmetic sequence from -4 to -1. We're adding 3. From -1 to 2, we're adding 3, and so on. All right, so that means that a sub k would equal, we take our first term, -4, we're going to add 3. And remember, we're adding 3, and instead of using n, we're going to use k minus 1, only because that was what we saw in the notation. So it's always k minus 1 because it's 1 less than the term you're on, and we need to simplify. So I'm going to distribute and then combine like terms. All right, so far I have, in my summation notation, I have my a sub k, so my equation for my sequence. Okay, and I know I'm starting at k equals 1. So now I'll have to find the only thing left, and that is to find n. And n is where you're stopping. So n is the term number of your last term. And our last term is 17, so we have to figure out what term number that was. So we had to figure out, if I know my equation, -7 plus 3k, and I know that my last term was 17, I have to figure out what the value of k was that gave us 17. So we're going to solve this equation, and we get that k equals 8. So now we have the summation notation for this series. All right, so if we are going to sometimes have a series that is infinite, that goes on forever, that we don't have our last term, it just keeps going, that means it's almost exactly the same. So I'm still starting at term 1. There's my recursive equation. I'm sorry, my explicit equation. And instead of stopping at the number 17, which was term 8, this does not have a last term here, right? This ... denotes that it goes to infinity. Now, I just want to mention, be careful if you ever see the summation notation written. Sometimes instead of having k equals 1 in the denominator, they'll use k equals 0. And then that means that we'll have to be careful about what term number our last term was. So for example, if we were doing that for our first problem here, if k equaled 0, then the n at the top where we're stopping would have been 7 instead. Okay, so just be careful that happens sometimes.